The directed network below shows the sequence of 11 activities that are needed to complete a project. The time in weeks that it takes to complete each activity is also shown. How many of these activities could be delayed without affecting the minimum completion time of the project? So this is a question to do with critical paths. So first of all, we need to identify which path is the critical path, and there may be more than one critical path. So identifying critical paths, plural, and then identifying the activities that are not on the critical path, they can be delayed. So recall that the definition of a critical path is a set of activities that any delay in any of those activities would delay the entire project. So let's do the forward scan. So starting with 0, 0 plus 3 is 3, 3 plus 7 is 10. Okay, now that 10 may have to change, so let's see, because there's another way to get to this vertex. 0 plus 4 is 4, so we've got 4 there. Now 4 plus 2 is 6, but we have a 10 there. 10's bigger than 6, so we can leave the 10 there, so that's fine. We got 0 plus 4 is 4, okay, and 4 plus 1 is 5, but then we have 4 plus 6 is 10, so we also have a 10 there, okay. So 4 plus 5 is 9, we've got 10 plus 2 is 12, 10 plus 2 is 12, so there's a 12 there. 12 plus 3 is 15. Okay, so we've completed the forward scan, so let's now do the backward scanning. So 15, so now we're using the second number. This is the LST, the latest start time. 15 minus 3 is 12. Okay, so 12 minus 2 is 10. Okay, and 12 minus 2 is also 10 there. Now, 12 minus 5 is 7, and we have 10 minus 2 is 8, 10 minus 6 is 4. So the lowest of the three numbers goes there. Okay. 10 minus 1 is 9, so that goes there. Now 9 minus 4, well that's certainly not 0, but we do expect a 0 there. Let's see here. So we've got 10 minus 7 is 3. Okay. And I think that's all of them filled in. Yep, that's fine. So now we need to identify the critical path. Now, this one, okay, we need to be just mindful. So this vertex here is certainly not on the critical path. Okay, so the obvious ones are this one here. Okay. So 0 plus 3 is 3, so this one is on the critical path, okay, so which means that is also critical as well, okay. 0 plus 4 is 4, this one is certainly critical as well, okay. Now 4 plus 5 is 9, but that's 12, so this one, there's some float time there, so I is certainly not on the critical path, okay. 10 plus 2 is 12, so this one here is on the critical path. Okay, notice also that the earlier start time, the later start time is identical and sort of on both ends, and you have a difference of 2, activity time of 2, that's certainly critical. This one here is critical as well, so okay. 4 plus 6 is 10, this one's critical. And that ends our critical path analysis. So let's have a look at it in a little bit more detail. We've noticed that there's 4 edges here that are not on the critical path. So we've got that one there, this one there, this one there, and this one there. So there's 4 activities that in fact have float time, a float time of anything other than 0 of course, so a float time of 1 hour or more, okay, or weeks, sorry, it's in weeks, so a float time of 1 or more, and that means that the answer is 4.